Question number 61. Incorrect statement among the following is. We have 4 different statements given here. The first statement, roasting of sulfide ore is thermodynamically feasible process. Yes, this is thermodynamically feasible process. This is the correct one. Further, zinc metal is used to extract gold from gold cyanide, AuCN whole twice. This is an ion which is given here. We should know that extraction of gold is also done by the process of hydrometallurgy, in which leaching is the process that's taking place. And when gold ore is treated with sodium cyanide, then there's the formation of a complex. And the anion that's shown here is the complex anion of that substance. So zinc metal is used to obtain gold from that. Basically, when this complex is treated with zinc, there is the precipitation of gold. It means this statement is also correct. After this, third statement, carbon anode is consumed in Hall-Héroult process for extraction of aluminium. We all know that this is a well-known process of extraction of aluminium. And yes, in this case, carbon anode is used and that get absolutely consumed during this process. This is also the correct statement. Now, carbon and hydrogen are suitable reducing agents for metal sulfide. This is a wrong statement because metal has more affinity towards sulfur as compared to carbon and hydrogen. That is why this statement is the wrong statement, and the correct option is option 4 on the basis of this discussion. Question number 62. When excess of silver nitrate is added to 200 ml of 0.05 molar complex solution, which complex it is? Tetraamine copper chloride solution, then the weight of silver chloride formed is. In this case, we have the volume and the concentration of this solution. We need to just find out the weight of the precipitate obtained. What is that? Is the precipitate of silver chloride. The process that's taking place here is the complex. This is the complex we have reacting with silver nitrate, and there is the formation of the precipitate AgCl, and another complex ion would be formed. This. And let me balance this reaction also. You will balance this as this way. Now in this case, you can clearly see that 1 mole of this complex is producing 2 moles of the precipitate of silver chloride. It means in this way you can calculate the moles of AgCl first, and those are equal to double of the moles of the given complex solution. And in this case, we have its molarity as well as its volume, and we know that moles is equals to molarity into volume, but volume you should take in liter. So molarity is 0.05, multiply it by volume, that is 200 ml. So we need to just change it into liter. Means you should divide it by 1000 in this way. So on dividing, you will get here, the zeros are cancelled, and this would be 0.02 mole. Now you have mole, you just want to find out the weight of silver chloride. So weight of silver chloride would be equal to moles into molar mass. Now what would be the molar mass silver chloride? Silver chloride, atomic mass of silver is given and the atomic mass of chlorine is also given. You just add them and you will identify that the weight would be 143.5, and when you multiply this you will get 2.87 gram. This is the mass or the weight of silver chloride obtained. It means we can easily choose here second option as the correct option. Now question number 63. The pair of colored species in the following is, we have different species given here. Certain are anion and some are the compounds. Let's check these species one by one. But before that, one thing I just want to make clear here, that color is due to DD transition of d electrons. Now again, if we talk about the first species, that is TiF6 2 negative. In this particular species, the transition element ion is present, that is Ti4 positive. It is present in 4 positive oxidation state. And what would be its configuration? That will decide whether DD transition is there or not. It means if it contains unpaired d electron, then definitely it will show color. But if it is not so, in that case the compound would be colorless. So in this case, titanium is there with 4 plus oxidation state, and here its configuration is 3D0. And if it is 3D0, it is colorless. Now further, the next compound that we have here is Cu2Cl2. It's a compound of copper, and the oxidation state of the copper in this particular compound is Cu+. And in this case, the configuration is 3D10. All the electrons are paired in d orbital, and that's why due to the absence of d electron, DD transition is not possible, and that's why it is again colorless. The next compound that we have here, COF6 3 negative in the second option. COF6 3 negative. Talking about the third compound. If we talk about first two compound, those two are colorless, and that's why there's no the possibility of first option to be correct. Now COF6 3 negative, in this case cobalt is there in 3 plus oxidation state, and the configuration is 3D6, and that's why due to the presence of unpaired electron it is colored. It means it can be the correct option, but we need to check next one also, that is TiF6 2 negative. We already discussed it is colorless. That's why second option is also incorrect. Third option we have COF6 3 negative. COF6 3 negative is the colored species. Then we need to check NiB4 2 negative. Another ion we have NiB4 2 negative. Just identify the oxidation state of nickel in this case. In this case, nickel is there in 2 plus oxidation state. And the configuration for this Ni2 plus is 3D8. That's why here is the presence of unpaired electron in d orbital, and that's why it is also colored. So third option contains both the species which have d electron, that's unpaired, and that is why these two species are colored species, and I'll choose it as the correct option. Now in fourth option, there are two species. One is Cu2Cl2 and other is COF6 3 negative. We already discussed here that Cu2Cl2 is colorless, while the COF6 3 negative is colored. But we need to choose that pair which contain both the colored species. That's why this is also not the correct one. It means this question has only one correct answer. That's given here in option 3. Question number 64. Number of rings present in the complex given here is. In this complex, you can clearly see that there is ethane 1,2-diamine is present as the ligand. And this ethane 1,2-diamine that's present here is the chelating ligand. And that's why this complex can be drawn as En is present here. We can show its structure in this way. And then I is there. And in this complex, how many rings are present here? 2 rings are there, and that's why option 1 is correct. After this, question number 65 I have here. Question states the given complex cannot show. What's the complex that's given here? It is cobalt. It is joined with 6 ligands. 5 H2O are present here. Say these H2O are arranged in this way. Now 5H2O we have, and one is NO2 that's present here. Now the question is there that this complex cannot show. If I talk about linkage isomerism is due to the presence of ambidentate ligand. And in this case, we have this NO2. NO2 is the ambidentate ligand. If we talk about this NO2, it is showing ambidentate nature because it can either be present as NO2 or ONO. It means there are two atoms which are acting as donor atom. That's why it can show linkage isomerism. It can be shown. Further, hydrate isomerism, due to the presence of water molecules, it can show hydrate isomerism also. Further, ionization isomerism, it can also show ionization isomerism as this nitrite ion can be exchanged with nitrate ion. That's why ionization isomerism can also be shown by this compound. If I talk about optical isomerism, it cannot show optical isomerism because it has plane of symmetry. That's why it will not show optical isomerism, and on the basis of this we can say this complex cannot show optical isomerism, and answer 4 is the correct answer for this question.